Hi, today in this lesson we're going to look at Unit 9, Day 7, Secants, Tangents, and Angle Measures. Our objective is today we will apply formulas to measurements when secants and tangents intersect. You should be able to find measures of arcs and angles based on the location of intersections. Recall yesterday we looked at the definition of tangent. The tangent is a line that intersects a circle in exactly one point. It is perpendicular to the radius. Remember, you may use the symbol for perpendicular if you remember it. Today we're going to talk about a new word. We're going to talk about secant. A secant is a line that intersects a circle in exactly 2 points. So for example, you can see this pink line hits the circle in 2 points. It is a secant. If a secant and a tangent intersect at the point of tangency, the circle will be divided into 2 arcs. The measure of each arc is 2 times the measure of the angle formed on the corresponding side of the intersection. Let's break that down. A secant and a tangent intersect at the point of tangency. So if I have a secant that intersects the circle twice, and a tangent that intersects the circle once, and the point of tangency for the tangent is also an intersection point for the secant, then the circle would be divided into 2 arcs. We can see I have a major arc here that I've highlighted in green and a minor arc that I've highlighted in pink. If the secant includes a diameter, you'll have 2 semicircles. The measure of each arc is 2 times the measure of the angle formed on the corresponding side. So for example, if I look at the angle that I've marked here in green, the green arc will be twice the measure. So if this angle is 100 degrees when I measure it, then the arc will measure 200 degrees. From there, we can figure out the other angle and the other arc. I know there's 360 degrees in the whole circle. So to find the other arc, I can take 360 and subtract the 200 from the green arc to get that the pink arc is 160 degrees. Then I can work backwards. I know the measure of the arc is 2 times the measure of the angle formed. So to find this pink angle, if I undo the 2 times, that would be dividing by 2, and I can get that this angle that I'm marking here is 80 degrees, half of the 160. Note that the 100 degree angle and the 80 degree angle are a linear pair, and therefore will always be supplementary. Label each arc and measure each angle measure. Let's start with number 1. When I look at number 1, I can see that they've given me arc AB, which is 130 degrees. So the angle that's going to match that will be half of the 130. That angle will be 65 degrees. So then to find the other arc and the other angle, I can use either supplementary angles for the linear pair, or I can use the whole circle's 360. That's the method I'm going to choose. This whole circle is 360. I've used 130 for the left side, the minor arc, so I'm going to subtract and find the other arc is 230 degrees. The angle that corresponds to that arc will be half of 230 degrees, which is 115 degrees. Let's move our focus to number 2, where they've given us an angle of 125 degrees. We need to find its corresponding arc, the other angle, and the other arc. You have 1.5 minutes to find those 3 values. There are 30 seconds remaining. You should be getting ready to show your answers. If you're in class, we should be showing our answers in 2, 1, and let's see your answers. All right, let's see if those answers are correct. The answers I got were for the major arc, we have 250 degrees, twice the 125. I took that away from 360 to get 110 degrees for arc KL, and the corresponding angle will be half of that, 55 degrees. If two lines intersect a circle, there are 3 places where the lines can intersect. The location of the intersection determines the formula used for finding angles. Okay, so when I look at this first one, I can see that my angle is on the circle. Here is the vertex of the angle we see. That angle has its vertex on the circle. It's an inscribed angle, which we've already talked about in this unit. We know that the inscribed angle is half of its intercepted arc. So in this case, if I fill in variables and I say the angle is x and the arc is a, I can substitute in the angle with x and the arc with a. So the value of x will equal 1/2 the measure of a. Now we're going to look at what happens if we are inside the circle. We talked about a central angle, the very first beginning of this unit. However, if I look at this point where it's inside the circle, there's nothing indicating that that's the center of the circle. So this is not necessarily a central angle. So instead, we're going to have to find another method. When I look at this angle inside the circle, the formula we will use is we notice there's an intercepted arc, which if this was a central angle, it would be equal to that. But it's not, so it's not. Notice the vertical angle on the other side of the angle we're working with would also have an intercepted arc that appears to be much smaller than the intercepted arc for the angle we are focusing on. We need to use both of those angles in our formula. Our formula will be the angle will equal 1/2 the sum of the 2 intercepted arcs. The angle will equal 1/2 the sum of the 2 intercepted arcs. So let's add some variables to our picture. If I think of the angle that I'm trying to work with as x, and the intercepted arc on the same side as that angle as a, and the intercepted arc on the other side that goes with the vertical angle as b, then I can substitute the angle with x will equal 1/2 the sum. That means we will be adding, and my 2 arcs are a and b. So the angle will equal 1/2 the sum of the intercepted arcs a and b. So we've looked at the angles on the circle, our inscribed angles, and we've looked at inside the circle when it's not a central angle. Now let's look at what happens if our 2 lines intersect outside the circle. So when we're outside the circle, I can see the vertex is an exterior point. Notice I don't have tangents, so I don't know anything about the lengths of the segments, but my angle is clearly outside. If I leave that angle, I'm going to first intersect this smaller arc, and then if I keep going, I'm going to intercept a second larger arc as the angle gets wider. I need to use both of those arcs to find my angle. For this one, my angle will equal 1/2 the difference of the 2 arcs. The angle will equal 1/2 the difference of the 2 arcs. Let's add some variables to our picture. I'm going to again refer to the angle as x. The first arc I come to, I'll call A, and the second larger arc I'm going to come to, I will note as B. So when I fill in my formula, the angle will be filled in with x. That's going to equal 1/2 the difference. When we do difference, we subtract. Here is an important thing you need to know when you're working with difference. We cannot have negative angles. So therefore, we need to make sure when we subtract, we're always going to subtract the outside bigger arc minus the inside smaller arc. So you'll always put the outside, the further away arc will always go first. So in this case, B is the further away, larger arc. So it needs to go first, followed by the A. So again, x will equal 1/2 the difference of the arcs, or B minus A. So just as a recap, when we look at our 3 circumstances that we can have on the circle, inside the circle, or outside the circle, when I'm on the circle, the angle is 1/2 the arc. When I'm inside the circle, the angle is 1/2 the sum of the 2 intercepted arcs. And when I'm outside the circle, my angle is 1/2 the difference of the 2 intercepted arcs. Let's practice using everything we've learned today. We're going to find each measure, and we get to assume that segments that appear to be tangent are tangent. That's important to know. So in this problem, number 1 says, what is the measure of arc WX? So if I look at W and I look at X, arc WX will be the shortest distance because it's only 2 letters. When I look at this, we're not working with an angle, so we're not using one of the new formulas from today. But I can see I've used 80 degrees and 160 degrees out of the whole circle. So when I put those together, I end up with a total of 240 degrees. I want to know what's left for just the blue arc. The whole circle is 360 degrees. I've used 240 degrees. So what's left is 120 degrees. That's the measure of arc WX. All right, next let's find the measure of angle Z. The measure of angle Z I can see is here. When I look at my formulas, I need to determine is that angle on the circle, inside the circle, or outside the circle. Angle Z is outside the circle. So I know I'm going to use the formula angle equals 1/2 the difference. So I'm going to take this and fill in the angle, and the 2 arcs will be subtracted. So my angle that I'm looking at is angle Z. That's going to equal 1/2 the difference. I have to do the outside arc minus the inside arc. So when I'm looking at my 2 arcs, first I hit 80, then I hit 160. We always want to use the bigger one first. So 160 minus 80. You can put this whole thing in your calculator at one time with appropriate parentheses usage, or you can solve it one step at a time. To do that, 160 minus 80 will be replaced with 80, and half of 80 is 40. So the measure of angle Z is 40 degrees. Let's look at the next set of questions. 3, 4, and 5. Number 3 wants to find the measure of angle FJE. So let's go find FJE. FJE is this angle right here. Now this angle, I can go back to way back to the unit 1 at the beginning of the year and notice that it is vertical with the angle across from it. So FJE will be 45 degrees. The 28 degrees we see in the picture near the angle is the arc from F to E. Number 4, find the measure of FJG. Let's find FJG. From F to J to G, is going to be this angle right here. Okay, so FJG is that pink angle. So then if I focus just on the pink angle and the 45-degree angle next to it, I can see that's a linear pair, which means they are supplementary. Out of 180 degrees, I've already used the 45 for the green angle, so left for the pink angle is 135 degrees. That is the measure of angle FJG. Let's go and find measure of arc GH. So here's arc GH. I can see it goes with the angle that's marked 45 degrees. But there's nothing that says that that's a central angle, so I don't know that GH is 45 degrees. I need to use one of my formulas. Is this angle on the circle, inside the circle, or outside the circle? That purple angle is inside the circle. So I'm going to use 1/2 the sum of the two arcs for the angle. When I fill in my formula, angle equals 1/2 the sum. I know the angle. The angle was given to me. It's 45 degrees. That's going to equal 1/2 the sum of the two arcs. So I'll be adding together the two arcs. One of the arcs is the arc we're trying to find. So I'm going to replace that with an X because we don't know what that is. The other arc is 28 degrees. To solve this, the first thing I want to do is move that 1/2 so that I don't see the fraction anymore. What I'm going to do, the opposite of multiplying by 1/2 or dividing by 2 is multiplying by 2, because 1/2 of 2 is 1. If I multiply the right side by 2, I also have to multiply the left side by 2. 2 times 45 will give me 90. That's going to equal, on the right-hand side, my 1/2 and my 2 will cancel out, and I'll just have x plus 28. If 90 equals x plus 28, I can use subtraction property of equality to find the value of x. The value of x is 62. So the measure of arc GH is 62 degrees. Let's do another example. We're going to be trying to find the minor arc and the major arc in this figure. And I can see I have two tangents in this figure. When I look at this picture, the angle that I've been given, the 50-degree angle, is it on the circle, inside the circle, or outside the circle? That angle is outside the circle. So I'm going to be using angle equals 1/2 the difference. When I look at this picture and I leave my angle, I can see my angle is 50 degrees. I need the difference of the two arcs. They have not given me any information about either arc in this picture. But I know I have this arc in between the 2 points of tangency, and I have the rest of the circle on the outside of the 2 points of tangency. And then they gave me a hint. It says think of the minor arc as x. So if I label my minor arc x, then the outside arc is the rest of the circle. If I knew what that x was, I would take it away from 360 to find the outside of the arc. But I don't know what x is. I'm still going to follow the same procedure though. I'm going to take the inside arc away from 360 to find the outside arc. And I'll leave it with the expression 360 minus the inside arc x. That's what I'm going to use for my formula. In my formula, I'm going to do the difference of the outside arc minus the inside arc. My outside arc is 360 minus x. Then I'm going to take away the inside arc. The inside arc is x. The first thing I'm always going to do is try to remove any fractions. To remove the 1/2, I'm going to multiply both sides by 2. When I multiply the right side, I also have to multiply the left side. 2 times 50 is 100. On the right-hand side, my 1/2 and my 2 will cancel out, leaving me with 360 minus x minus x. I can combine those two x's. Minus 1x minus another x is minus 2x's. From here, I need to get the minus 2x all by itself. I'll use the subtraction property of equality to remove the 360. When I do that, I'm going to get a negative 260 is equal to a negative 2x. Then I can use my division property of equality and divide both sides by 2, which is going to give me an x value of 130 degrees. I'm going to add that to my picture. I can use that to find the outside arc, which is 360 minus the inside arc 130, so that outside arc is 230 degrees. Now we need to make sure we get the right one in the right blank. The first one wants the minor arc. That would be the one that's less than 180 degrees, the 130 degree angle. Then we want the major arc. The major arc will be 230 degrees. Let's look at number 7. We want to find the measure of angle QRS. When I look at angle R, or angle QRS, I need to determine, is it on the circle, inside the circle, or outside the circle? This angle is on the circle. It's an inscribed angle. We've done problems like this before when we first looked at inscribed angles on day 3 of the unit. I know that the angle, the measure of angle QRS, is going to be 1/2 the arc. So I need to determine what is the value of arc QS. In the 360 degrees of the circle, I can see I've already used 120 degrees and 40 degrees. So I've already used a total of 260 degrees out of the 360 degrees in the circle. When I take away the 260 degrees from 360 degrees, I know the arc is 100 degrees. That's what's going to be replaced in my formula. So the measure of angle QRS will be 1/2 of 100 degrees, which is 50 degrees. Let's look at number 8. Find the measure of angle R. Angle R is located here, on the circle, inside the circle, or outside the circle. Angle R is outside the circle, so I know I'll be using angle equals 1/2 the difference. You have 1.5 minutes to find the measure of angle R. There are 30 seconds remaining. If you're in class, you should be starting to write your answers on your paddles. You should be ready to show your answers in 5, 4, 3, 2, 1. Let's share our answers. All right, let's see how we did. The measure of angle R equals 1/2 the difference in the arcs. The bigger arc has to go first, so that's 1/2 of 40. The measure of angle R is 20 degrees. All right, we have another number 6. The numbering got a little off. Number 6, find the measure of angle X. Here's the location of angle X. Is this on the circle, inside, or outside the circle? This angle is inside the circles, so we'll be using the angle equals 1/2 the sum of the two intercepted arcs. You have 1.5 minutes to find the value of angle x. There are 20 seconds left. You should be writing your answers on your whiteboards if you're in class. All right, be prepared to share your answers in 5, 4, 3, 2, 1. Let's see our answers. All right, let's see how we did. The angle will be 1/2 the sum of 52 and 40, which is 92. So the measure of angle x is 46 degrees. Number 7, I'm trying to find the measure of angle V, which is outside the circle. You have 1.5 minutes to find the measure of angle V. "30 seconds remaining. All right, be ready to share your answers in 5, 4, 3, 2, 1. Let's share our answers. How did we do? We were looking at the angle equals 1/2 the difference. I needed to find that inside arc, so I had to add the 3 arcs that were given to me, 110, 100, 80, for a total of 290 out of the 360 degrees, leaving that inside arc as 70 degrees. So then in my formula, 100 degrees minus 70 degrees is 30. Half of that is 15. The measure of angle V is 15 degrees. Let's look at number 8. Number 8, find the measure of angle x. You have 2 minutes. 1 minute remaining. Thirty seconds remaining. Ten seconds remaining. Be ready to share your answers in 5, 4, 3, 2, 1. Let's share our answers and let's see how you did. Did you get an answer of 110 degrees? If you did get an answer of 110 degrees, unfortunately, that is not the correct answer. We should not have a box around that answer. Let's talk about why. Our math here is good. The angle is 1/2 of the sum of 130 degrees and 90 degrees. If I look at those two intercepted arcs, however, the angle that goes with them is not the angle x that we were trying to find. The angle we found is the adjacent angle to the angle we were trying to find. So to find the value of angle x, I have to remember that these two angles inside the circle are a linear pair and therefore are supplementary. So 180 minus 110, the angle I was trying to find is really 70 degrees. This is a very common mistake that's easy to make, so you need to be careful that you're finding the angle that you're supposed to find. You sometimes have to find a different angle first. We did have to find the 110 degrees in order to be able to find the 70 degrees. All right, let's look at the last problem. This is going back to the very beginning of the notes, so you might have to look back in case you already forgot how to do this problem. But you have 2 minutes to find the measure of arc TR and the measure of arc TSR. One minute remaining. Thirty seconds. Ten seconds. Be prepared to show your answers in 5, 4, 3, 2, 1. Let's check our answers. All right, how did you do? Did you get 164 degrees for the measure of arc TR and 196 degrees for the measure of arc TSR? Or did you get them backwards? Remember, your minor arc will be named with the 2 letters, and the TSR has to include the side with the S in it. All right, please make sure that you wipe off your whiteboards and return the eraser and the marker to the holder. Let's review our objective for today. Today we applied formulas to measurements when secants and tangents intersected, specifically inside, outside, and on the circle. You should now be able to find measures of arcs and angles based on the locations of those intersections. You'll show me that you can do this by completing the independent practice 9.7, which is due on Thursday. That's tomorrow. Thank you so much for watching.